Hello again. Today we'll be looking at natural numbers and place value. So, a little bit of a history lesson. Um, the idea of numbers kind of started around the Egyptian times and Babylonian times, and then kind of around the Greek times it was further introduced. And why was it introduced? Well, we needed to count things. Very simply, if you were a farmer, you needed to count how many sheep you had. If you were a merchant, you had to count coin. So there had to be some kind of system put in place to count things, and everybody had to use it, obviously. So we invented these things called counting numbers, and the term we use in mathematics is they're called natural numbers, and they're for counting things. And everybody knows them. You learned them in primary school. They are 1, 2, 3, 4, 5, 6, 7, 8, 9, and now it keeps on going. I just didn't have enough space on the slide. 10, 11, 12, 13, 14, 15, 16, 17, 18, and so on. But they're all the numbers all the way up to infinity. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, just to note, it does not include 0. So we start with 1, 2, 3, 4, 5, 6, 7, 8, 9. It doesn't include 0. Also, it doesn't include any fractions, so we're not looking at a half or 2.8 or anything like that. It's just your whole numbers. Another thing, back in the day, they didn't really consider negative numbers because they were looking at things that existed. They didn't really need the negative numbers back then. So natural numbers just are all the positive whole numbers, and it doesn't include 0. So I'll say that again. It's all the positive whole numbers that doesn't include 0. And that's the official definition of natural numbers. Sometimes in an exam you might be asked, "Oh, what's a natural number?" That's what you'd give. You'd get full marks for writing that down. Then I said we talk about place value. So what do I mean by place value? Well, if I was to read this number out loud, it would be, 382. Well, how did I get that? Well, there's this 3 represents 3 hundredths. This 8 represents 80, or 8 tens is what we might call it. And then 2, well, that's just 2 units, 2 units by itself. So what do we mean by place value? Well, it's where these numbers lie. So this 2 represents 2 ones. This 8 represents 10, so it's 8 tens, which is what we call 80. And this 3, the place value of this 3, well, it's the hundredths, so it's 300. What about this one? Well, again, I'll just read it out first. I'd say it's 4,074. How did I get that? Well, there's 4. This 4 here represents 4 thousandths. This 100, well, there's no hundredths. It's 0, so there's no hundredths. The 7 represents your tens, so that would be 7 tens, so it would be 70. And now this 4, it's different to this 4 over here. It's different. This 4 represents your ones or your units. So if I was to read it out, 4,000, yeah, and 74. That's how you read it out. And if you were asked in an exam, where did this actually come up, or why do we care about it? Well, they'd say, okay, well, a question you might get is, what is the place value of this 7? Well, it'd be tens. It would be the tens, so it would be 70. Now, a bit more common is decimal place value. Now, and this is, bear in mind, we're not talking, this is not a natural number. Yeah. Natural numbers are only positive whole numbers. This is not a whole number. Well, the place value, what about with the decimal point? Well, we have 12, so that's your 10, your ones. This, well, 0.35. Now, what does the 3 represent? Well, the 3 represents your tenths. The 0.3 represents your tenths. and the point 0.05 represents your hundreds. So the way I like to think about it is you start with tenths, hundreds. What do you think the next one would be? Well, it would be thousands. Tenths, hundreds, thousands, 10,000s. So you're just adding a zero each time. So 10 is 10. Hundreds would be 100. Thousands would be 1000, and so on. So that decimal point, this is a more common question. They'd say, okay, well, what's the 3 represent in 12.35? Well, it would be tenths. Yeah? Now, this is a big, awful chart, but it's just kind of an outline of if you were given any number, well, not every number, but most of the numbers you'll encounter, you could read it off with this. So let's say I had a number like this. Okay, well, it's 1, 2, 3, 4, 5. So your decimal point is here, yeah? This represents a decimal point. 1, 2, 3, 4, 5. So this represents 10,000s, and we can actually just read it off. You would say this is 30,000. That's 4,000. This represents 550. So if we were to read it off, it would be 34,550. And there's no ones, yeah? So that's to the left of the decimal point. I was looking at all these. Now, what about to the right? Well, 0.987. Well, the 9, what does that represent? That represents tenths. Yeah? Next one, as I said, you're adding a zero each time, so tenths. The 8 represents hundreds. The 7 represents thousands. So this is a nice little handy chart. You'll eventually just learn it off and you'll know it intuitively. But if you're a bit stuck trying to figure out, well, how would I know the place value of the digits? Well, you could just look at this kind of chart and get used to it. So just some recap questions, as we always do at the end. So what are natural numbers? You were asked this in an exam. What are natural numbers? Or just anybody asks you, what is a natural number? How do you describe it? And then the other question is, what values do the 5s represent in 516.25? So there's a 5 here and a 5 there. So what do they represent? What's the place value? Yeah? So I would recommend you pause the video and do them yourself. But the answers anyway are, what are natural numbers? This is the official definition: a whole positive numbers not including 0. There you go. What do the value of 5s represent in 516.25? Well, the 5 represents 500, and this 5 is 500ths. Careful now, there's a difference between 500 and 500ths. Yeah? Different question.